In this lab, we will be investigating the law of reflection and refraction. We'll be using our light source as a source of a light ray. You'll want to rotate that dial to a single slit to produce a single ray. We'll be reflecting that ray off three surfaces of the mirror: a flat mirror, concave mirror, and a convex mirror. And we will investigate the law of reflection. We'll be using a simple pencil, ruler, and protractor to measure the angle of incidence, angle of reflection, and we'll see um, experimentally confirm that the angle of reflection should equal the angle of incidence. So in this case, we will be using light source in a horizontal manner. You want to rotate that dial to a single slit, and that will serve as a light ray. Okay, so that will be our approximation for a light ray. We want to reflect that light ray off the three surface mirror as we mentioned before. And this is what you want to do first. You want to determine the normal line to all three surfaces. So go ahead and trace that mirror out and determine those normal lines as the procedure indicated. And then simply vary the angle of incidence, which is measured from the ray to the normal line, and measure the reflected angle. And one way to do this is to use a pencil to mark one single point along the ray and make sure the ray is hitting the center there of the normal line, so you can draw a straight line for the incoming ray and the exiting ray. And you want to do several angles. I think you want to do three angles, so vary the angles, three different angles, and make sure it's hitting right there at the starting point of the normal onto the surface, so you have that one point, and then you simply draw in another point. You connect those 2 points using the ruler, and that will be your incoming ray and your exiting ray. So make sure you're being careful with drawing these a light ray. And once you have that, then you can then use a protractor to measure the angle of incidence and the angle of reflection. And you'll want to do this for three angles of incidence for each surface: the flat surface, the convex, and the concave. Again, keep in mind that the angle is measured from the ray to the normal line. Next, we want to study Snell's law, or the law of refraction. Here we'll have a rhomboid, um, and sorry, not a rhomboid, but rather a half of a cylinder here, and we will want to vary the angle of incidence, and that can be done simply by rotating the platform, and take a note of the exiting ray. So what we want to measure is the angle of incidence and the angle of refraction, and then apply Snell's law to determine the index of refraction of the acrylic. Here we now have the rhomboid. Here we're going to be investigating the dispersion of light. So first of all, you want to go ahead and trace out that rhomboid and determine the normal line to the angled surface. Again, simply use a projector to measure that normal line, and a 45-degree line to the normal line. That would be the direction in which the incoming ray is coming. Now, the index of refraction is going to be this the same for a material, but it can be different depending on what the wavelength is. It's the same for the wavelength, but white light have several different wavelengths, so there'll be a different degree of bending for each wavelength. So you're simply filtering white light into its rainbow color.